Hello everyone. We are starting a free open lecture in our Discord. All our lectures are held weekly without breaks. If you, the viewer, want to ask questions and receive answers in an online format, join our lectures. You can find the link to Discord in our Telegram channel. To find out the time of the lecture, join our Telegram channel. Now let's move on to the disadvantages. They do exist. Despite the fact that Docker is a very cool and seemingly universal tool, it has its drawbacks and cannot always be used. There are moments when Docker is either very difficult to use, but can still work through workarounds, doing what we want, or it may be completely impossible, and I will talk about that too. The first challenge of managing containers at a massive scale is that if we have some colossal product like Yandex or Google, anything that has a lot of containers will emerge because there are many applications, especially if it is a microservice. Then we can say that almost every class is in a Docker container. Managing all of this in Docker can be quite challenging. If such a situation arises, it is better to use Kubernetes. It is better suited for projects that involve a colossal amount of code and a vast number of various services. They are simply easier to manage. Then, limited performance. In some cases, containers may not be able to provide the same performance as on a real operating system. In fact, the performance of a container will always be worse than that of an operating system purely because of our hardware, such as the processor and RAM, and also our operating system, definitely. The next level is just literally right nearby, and here we have Docker, a container technology. He will definitely need to go through the engine and then through the operating system, and only after that will he reach the hardware. There is a difference in the paths that need to be taken from the operating system to the processor, for example. From our application to the processor, it is already evident that there are many more steps to take in a container. As a result, the efficiency will be lower. The same situation applies when comparing it to a virtual machine. Here we have the application, and right over here is the guest operating system. That is, from the application to the kernel, it takes 1 or 2 steps. And for a container, if we look from the application.
Want to become a great programmer? Subscribe to our Telegram channel.
To the core, it will be 1, 2, 3 steps, even more. Then there is a point in the advantages that it is portable, but in reality, this point comes with an asterisk. In principle, regardless of the operating system, yes, Docker containers will most likely work the same on any operating system. But there may be potentially some limitations related to the architecture. For example, the processor. The overwhelming majority of modern processors have an x86 architecture. Accordingly, a lot is developed for the x86 architecture. But there are some MacBooks, and now other laptops have started to be made, that use processors with ARM architecture, especially on mobile processors. And these architectures differ significantly from each other. Some processor instructions that exist on x86 cannot be executed natively on the ARM64 architecture. Accordingly, there may not be certain images or applications available here. Let's say ARM64 is a real case. This has happened before. Therefore, the portability is enormous. But there are some nuances. And also the last drawback is that not everything we want can be packaged into a container. For the obvious, Docker does not natively support GPUs yet. If you need to perform computations on specific computational processors, such as for training neural networks, native Docker will not be able to do that. There are some somewhat makeshift options, such as an extension for Docker that will allow it to interact with computing processors internally. For example, if we take MacBooks with the new M series processors, they have Apple Metal, which, like CUDA, allows for accelerated training or computation on their processors, meaning it can perform calculations similar to a graphics card. This is not supported in Docker at all for now. There are issues with neural networks, for example, or if we are making a graphical application with an interface, there will be problems. This can be done, there are solutions, but again, it is not a native standard use case for Docker. In Docker, usually something more network related is run, like VPNs or maybe some web applications. That's okay in Docker. As for graphics, where performance is needed, games in Docker, it's not advisable, because the performance will be poor, clearly worse than on a real operating system. Well, there are some development options that are simply impossible in Docker, but the most obvious is something low level. Either the development of an operating system in general, or the development of drivers for specific devices. This must be done on a real operating system to be as close as possible to the devices, to the hardware, because we are writing for the same drivers. It is important to note that this approach ensures that the software will be compatible with the intended hardware and perform optimally. Regarding Docker, it doesn't make sense because we have some device, and there will be 1,001 levels of abstraction above that device. In the end, we will never be able to interact with the hardware itself in Docker. We will only interact with the layer from Docker, and we won't be able to access the hardware. Very deep networking tasks may not always be feasible. If we need to configure the network at a very low level, it won't be possible in Docker for the same reasons, as there is a level of isolation. However, Docker does have quite extensive functionality for interaction. In the next class, we will see what additional information else needs to be written in the Docker file. We will run some simple application without a connection, then yes, we will move on to Docker Compose. A setup over Docker, you could say it's a plugin that allows you to run a multi-container application. That's what it will be. And probably yes, at the end we will try to run something. Well, the code will naturally be simple, but to have, let's say, a few services, 3 of them, that can communicate with each other, while each service is already a Docker Compose application, how can we implement that? So yes, it will happen. This is basically the plan for the next lecture. The next lecture will mainly be practical, ranging from something elementary to something that I wouldn't say is difficult, but rather not elementary. Well then, the homework is quite simple for you. If you don't have Docker installed yet, you need to install it. It's best to install Docker and Docker Desktop for a GUI, and not everything has to be typed manually in the terminal. Very useful. At first, it is indeed advisable to type everything manually in the terminal to understand what commands are there, and to grasp how many things work in general. However, later on, it won't make much sense, and clicking a couple of buttons will be much faster than writing out a command. So it is preferable that everyone has Docker Desktop installed by the next lecture. It is cross-platform and will install both Docker Engine and all the necessary dependencies that we will need. Thank you all. Then, see you at the next lecture.
Want to become a great programmer? Subscribe to our Telegram channel.